Okay, good morning, everyone. So I wanted to talk to you about 1.5 and teach you a few tricks to help you with the homework, and so that way you can get it complete. So your chapter 1 test will go smoothly after you have done the review that I need to post. Um, the reviews and tests will be online. The reviews are there to serve for a springboard to get you thinking about topics in chapter 1. All right, so number 1, solve the following equation. I'm going to stay here for this one, but I subtract 7 on both sides, so that'll give me 3x equals 3. So therefore, x is 1, because if you divide 3 on both sides, you get 1. Okay, number 3, this one has a few fractions in it, so I need to go to my scratch work. And if you want to see how I did 1, there it is. I also checked it. That is a valuable skill to do or to use when you're solving equations. All right, number 3. So 1/4 y minus 1 equals 1/3. So what I did was I added this 1 to both sides. And then I added these two together to get 4/3. Lastly, multiplying by the reciprocal to isolate y to get 16/3. Number 5 had no fractions. I combined like terms. 7x plus 6x is 13x. I dropped the minus 3 down. 4 minus 6x is minus 2x. Drop the 5 down. Add 2x on both sides. I get 15x minus 3 equals 5. And then I added 3 to both sides to get 8. So then I just divide by 15 on both sides to get x is 8/15. Let's go back to the 1/5. Okay, so that's how I got the answer for 3. And here's the answer for 5. Okay, this is the one I just explained to you. Now let's go to number 7. So in 2008, 34.6% of all tax filers didn't pay income taxes. This percentage is 8.7 percentage more than the percentage of filers in 99 who paid no income taxes. Okay, that's a key sentence, so I'm highlighting it. I'm going to change that English into mathematics. So we are supposed to find the percentage of tax filers who paid no income taxes in 1999. So that last sentence is going to represent our variable, and I'm going to call that x. So now let me show you my scratch work. Okay, I wrote down the important information. I'm saying let x equal the percentage of filers in 99 who paid no taxes. So now the equation we come up with from that highlighted sentence that I just highlighted earlier is 34.6 equals 8.7 plus x. Okay, so this percentage was the 34.6, so I dropped that down here. Is means equals. 8.7 comes here. More than means plus, and then all of this underlined represents x. So then I solve for x to get 25.9, and that's a percentage. So that's how I came up with the answer there. Number 9, money is borrowed at 7% simple interest. After 1 year, 1104.24 pays off the loan. How much was originally borrowed? So I'm telling you right now that quantity is called P, which is the principal. So in this loan, to pay it off, you have to pay the principal plus the interest. And the formula for simple interest is PRT multiplied. So what I did was I factored a P out to get 1104.24 equals P times 1 plus RT. And then it looks like I divided both sides by 1 plus RT to get this value for my principal. And lastly, I plug in my rate. Okay, my rate is 7%, so I use 0.07. So then dividing this out, you get 1032. So think for a moment. Is the total amount to pay off the loan more or less than the principal? Well, the principal should be less than the total amount of the loan. So it seems reasonable. Let's go see what Pearson has to say. Okay, so for number 9, this is how Pearson words it. And sure enough, 1032 is the original amount borrowed, or the principal. Okay, question 11. A lady works 44 hours one week and earns $437. She gets time and a half, which is 1.5 times her regular wage for the number of hours she works over 40. What's the regular hourly wage? Okay, so this is our variable right here. So let me show you the work for this one. Okay, I changed it to man, but you can think lady if you want. But I basically rewrote the question. I'm going to say let W equal the man's regular wage. The numbers are all the same. I split up the amount of hours he worked into 40 plus 4 hours, because this 4 hours is his overtime rate. So then I said, let's make an equation. So 40 hours times his hourly wage plus 4 hours times his time and a half wage should equal 437. And I wanted to show it to you this way to show you, yes, do the units check out? I mean, notice these hours cancel, those hours cancel. So I have dollars plus dollars equals dollars. And that's what I need for an equation to work. The units on one side of the equation must make sense with the other side. So then I add these two together to get 46W equals 437. And then I divide 46 on both sides. 437 over 46 is 9.5. And again, that's going to be in dollars per hour. Okay. So that's what W is. W is the man's regular wage in dollars per hour. So that's the answer. Okay. Let's go to number 13. Sarah takes out a loan for $2,100. After 1 year, Sarah decides to pay off the interest, which is 6% of 2,100. How much will she pay? This is just a I equals PRT question. The principal is 2,100. The rate is 0.06, but notice this percentage changed to a decimal. The time was 1 year. So the interest is 126. So number 13, they're just after the interest. Okay, and there it is, 126. And this is the way Pearson worded the question, and my numbers were exactly the same. Again, if you want more explanations, you're welcome to click here. Number 15, find the zero. So that's the same as the x-intercept. So then let's show you that one. Wherever there was an fx for y, I replaced 0, subtracted 11, divided by -4, and I got 11/4. So that's where the graph will hit the x-intercept. So we call that a 0. It's a linear function, so that's a straight line. Number 17. Find the distance between these 2 points. Okay. Here's the distance formula. I recommend you memorize it. But I found delta y by subtracting these two, and delta x by subtracting these two. Delta y was -9, delta x is 12. So we know delta y is just subtracting the two values, or the change in, so that's -9. And then delta x is subtracting my 2x values, and that was 12, which I found from up here. Simplifying, I get 81 plus 144 underneath the radicand. So I get square root of 225, which is 225 is a perfect square. So 15 is the distance between these 2 points. And that was number 17. Again, if you want to look into the textbook for the argument of how they derived the distance formula, you are more than welcome to do that. If you're majoring in mathematics, you may want to think about that. It also may help you in some of your other science courses to understand where the formula comes from. So I'd recommend that if that's your major. All right, so now let's get you a new share here. I wanted to show you 1/6. Okay, 1/6 is here. I'm reminding you, hey, get your chapter review and your test done, and look at the syllabus for the due dates, and please stay on track with assignments so they don't pile up at the end. Okay. 1/6. All right, here's the first one. Take a look at it, internalize it. And while you're doing that, I'm going to pull up 1/6 homework, which is due. Okay, so hopefully you've stared at that question and you kind of understand what's going on. We're graphing inequalities after solving in this section. So here's 1/6, number 1. Okay, this is what it looks like. Solve these two. So I subtracted 7x and I got 2x minus 1 is greater than 9. I added 1 to get 2x is greater than 10 divided by 2. That's where I came up with the x greater than 5. To graph that, it looks like this. The parenthesis corresponds to the greater or less than. Number 3, a little more complex. Let me show you my work. Okay. So here's number 3. 8x plus 3 plus x less than 1 plus 5x minus 14. These two combine to 9x, drop the 3 down, drop everything else down, while combining 1 minus 14 is negative 13, drop the 5x down. Then I decided to move the x's to the left by subtracting 5x to both sides to get 4x here, and then I also moved this positive 3 here by subtracting 3 to get negative 16. So 4x less than negative 16, divided by 4, you get x less than 4. This is inequality notation. This is interval notation. So negative infinity is my lowest x value that will work, and negative 4 is the highest. So that's important in interval notation to put low value, comma, high value. Okay, and because this was less than, we use parentheses. But anytime you use infinity, you're going to use parentheses, not brackets. Number 5, compound inequality. I added 1. Negative 3 is less than or equal to x is less than or equal to 5. So because this is less than or equal to, you use bracket. Graphing, it'll look like this. Negative 3 to 5. Every number in between will work in this compound inequality. That's what the graphical solution means. You can test it. Put in 0 for x. Sure enough, if you cover the x, negative 4 is less than or equal to negative 1, and that's less than or equal to 4. Number 7, another compound inequality. It looks like what I did was to get rid of this 1/2. I multiplied 2 everywhere, okay? So this 1/2 times 2 is now gone because that's 1. 5 times 2, I just left it to show you, hey, I did multiply everywhere by a 2. Anyway, the next thing I did is I subtracted 8, simplified, so that's negative 10 minus 8. So that's where I came up with this. This is now gone, so I dropped the 2m down. So 20 minus 8, I write there. To get 12, drop down. This is negative 18 now. And so now I just divide everywhere by 2 to get negative 9. Less than m, less than or equal to 6. Notice this is less than, so I have parentheses. This is less than or equal to, so I have bracket. Graphing, it looks like this. Okay, so believe it or not, we're on 7, and that's the solution here. They're asking you to select the correct graph, and this is what it will look like in Pearson. Again, you can look here if you need more help. Okay, question 9, moving right along here. So I have an OR inequality. You just treat that separately and solve. For those of you who need it, let's show it to you. I converted negative 8/10 into 14.2, and by doing so, I had to add 15. So I added 15 to both sides to get this. Divided by 2, I got x less than or equal to 7.1. So this one's taken care of. Now we come here, add the 15 to both sides, you get 15.8. Divide by 2, you'll get 7.9. And this is what the graph looks like. Okay, number 11. Last question. It's fill in the blank. So what I've underlined is the blank. A function is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to exactly one member of the range. So that should finish you up for 1.6 lecture. And here it is. This is what it will look like. You put the answers here. So thank you for watching, and I hope you take advantage of all the resources. NetTutor is great. Try out NetTutor if you're running into issues on the online homework, if you're falling behind. All right, thank you again, and have a great day.